Okay, here's some of my favorite questions, solving logarithmic ones. So here's one where they're looking for an answer for x. What value of x would make this statement true? You can try and plug some numbers in, but you're going to have to do some calculations. If this question would have been 3 to the x equals 3 to the x minus 1, maybe you can solve that one, but you'd have common bases. Then you could just say x is equal to x minus 1, and this one I think there'd be no solution for that. But in that case you can use common bases, but in this question the bases are different, so you can't use that. So what you can use is the power rule, and the power rule lets you get at those exponents. And so to apply the power rule, what you do is you take the log of both sides. So in the solutions, I think they say to use ln, but it doesn't matter. You can use log base 10 of 3 to the x equals log base 10 of 2 to the x minus 1. I think in the book solution they go ln of 3 to the x is equal to ln of 2 to the x minus 1. Both these ways are going to be the same thing. And so in this case here, I can now bring that x out front. So I've got x times log of 3 is equal to x minus 1 times the log of 2. And now what you do is you figure out what the log of 3 is, come up with something on your calculator, it'll be point something. Same thing with the log of 2, and you'll use the distributive property in that case there. You'll collect your x's, get them together, and solve for x. Always make sure at the end that you check to see if your answer is right. Okay, so that one, you can use ln, but you could use log 2. You're going to come up with the same answer. Another question, a little bit tougher, this one, involves using the number e as a base and having these exponents here. What they suggest to do in the book is first multiply each term by e to the x. And so if I take e to the x, e to the x, and multiply it by e to the x, multiplying common bases, add their exponents, so that'd be e to the 2x. Then you do the same thing with this one. But this one, when you have e to the minus x times e to the x, multiplying common bases, add their exponents, negative x plus an x gives you 0. So you get e to the 0, and anything to 0 power is just 1. Okay, is equal to 5 times e to the x. Then you reorder these, and what we're looking for, and what they're looking for in the question, is to get this in a quadratic form. So this is almost like x squared, and this term would be the x term, and this would be the constant term. So bring this one to this side and make it negative. So it would be minus 5e to the x plus 1 is equal to 0. Now since it's sort of that quadratic form, then you can use the quadratic formula. Plus or minus the square root of b squared minus 4ac all over 2a. A here is 1, b is negative 5, c is a positive 1. You can plug those in and solve for x. And then you can do some stuff after. You have to do some stuff after that because there's still a ln involved there in order to determine what your answer is. Well, let me just slip to that and just show you in the answer key what they have. So 25 right up here. Whoops. I gotta move up a little bit. Anyway, going up a little bit. Delete. Right here. Oh no, where'd it go? Oh shoot. Here it is right there. So they multiply by e to the x, and then it's quadratic in nature, so they use a quadratic formula to solve. So e to the x is equal to that stuff, and then they solve that. I'm not going to give you a question like that on a test. That's sort of pushing the envelope a little bit. You won't see one like number 25 on the test. Okay, hopefully that helps out.